All right, guys, obviously I've gone from the whiteboard to my teacher's manual. Here's the answers to those three problems. Remember, cross products. That is what we are using to find the unknown. And we know that these are equal to each other. Therefore, by using cross products, we can find the unknown. And so one problem I'm already seeing is students trying to do it in their head. We want to write out the equation first and then solve it on paper. Please don't do it in your head. We should see equations like this. Alright, so let's move to this word problem here. And I'm going to highlight stuff to really bring it out and so you can see what's being compared and how to build your proportions. So let's read the whole thing first. Trina earned $28.50, right, for tutoring 3 hours. Write an equation that relates her earnings, M, so that's yellow or money, to the number of hours, we're going to make orange. Assume the situation is proportional. That means we can assume that these are going to be set equal. How much would Trina earn tutoring 2 hours for tutoring 4.5 hours? So let's set up our proportion. We know that she makes $28.50 in 3 hours, right? And so I'm going to color code that. $28.50 in 3 hours. It says it's proportional, so we know it's equal. And then so here we have to be careful. We want it for 2 hours. So this is money, this is hours. Do we place that 2 here or here? Well, we'd place it here because we want to keep them in the same position. All right, what we don't know is how much was spent, right? So now by cross products, we can solve it. Let's set up the other one. Again, we're comparing it to $28.50 in 3 hours, and we can set it equal. Why? Because it says it's proportional. And now we want 4.5 hours. Was that the top or the bottom? Well, hours is on the bottom in this instance, and we can set it equal to X. Or, more specifically, I guess it should be M for earnings, but that's fine. So that's how you set them up. Cross products then allows you to solve for X. And so the answers to that are here. I'm going to circle them. I'm going to cover that. There's your answers. All right, so you solve it and check it. I'm going to do 2 more word problems on the next page, page 59. Let's see, are we there? Yeah. All right, nice. Let's look at this one. Now look at the instructions. It says assume situations are proportional. So we already know that they're going to be proportional. They're already equal. And because they're equal, we then can use cross products to solve for the unknown. Eduardo paid $1.12 for how many eggs? A dozen eggs. So how do we write that? Well, there's your money over your eggs, 12 eggs. So I'll put an E for eggs. We know it's going to be equal to another rate. Making it a proportion is determine the cost of 3. So does a 3 go here with eggs or with money? It has to go down here, right? What's the unknown? The cost. So we'll put T. So you would use cross products to solve for that. Now you might see very quickly you can divide by 4 over 4, but let's use cross products. So we know that T, 12T equals 3 times that, which is 3 times 1. And from there, you would multiply and then you would solve for T. The answer should be 28 cents. 28 cents. Okay? Let's look at this one. Now this one's a little different. So now before I do this one, I want to show you this idea. Let's pretend there's a jar and we have 3 yellow marbles and we have 2 red marbles. And if I said I want you to make a ratio of red to yellow, it would be 2 to 3. Is that true? Yes. But now What if I said I wanted you to make a ratio of red to all the marbles? At this point, you have to add them all up, right? To get all, that's 5, and red would be 2. And so what I'm trying to point out here is sometimes the ratio will be between the two quantities in the group. Sometimes it's going to be a ratio of part of the quantity to all of it, all right? And sometimes students make the mistake of they don't, because the ratio was red to all, when they calculate all, they leave out red. And that's where you have to be careful of your ratio. And this next problem does something like this. So let's look at, this will be my last problem for this short video. Sheila mixed 3 ounces of blue paint with 2 ounces of yellow paint. She decided to create a 20 ounces of the same mixture. How many ounces of yellow paint does Sheila need to make the new mixture? All right. Wow. So let's read it again. Sheila mixed 3 ounces of blue paint with 2 ounces of yellow paint. Right? So she mixed those together, and so now you have this 5-ounce mixture. Do you see how we had to add those together? I'm not necessarily pulling them apart. She decides to create a 20-ounce one. So here we go. I'm going to write mixed. Here's mixture. At this point, we have one that's 5, and here another one for 20, because she mixes those together, and now she decides to make a 20-ounce mixture. How many ounces of yellow paint does Sheila need for the new mixture? So what's our top? What's the top part? It's yellow. So now we have to go back and fish out yellow. 3 ounces of blue paint? No. 2 ounces of yellow paint. And what's my unknown? How many ounces of yellow do we need for this mixture? Use cross products. All right, so 2 times that is 40. 5 times that is 5y. Divide by 5, y equals 8. Do you see how we solve that? What's most important is that you be really careful setting up what are you comparing, and then what is it asking. You have to take your time. Here it wasn't just blue to yellow, it was actually yellow to the whole mixture. So this is where you have to be careful. All right, guys, see you tomorrow.